Hi, this video is going to be on multiplying and dividing fractions. One thing that I wanted to point out just very quickly, fractions are a rational number, which means they are also a real number. Every real number still follows the same rule, that if I have a negative times a negative, it is a positive. If I have a negative times a positive, it is a negative. And obviously a positive times a positive is still a positive. So, that being said, I just want to throw that out there real quick, because when I first look at a problem such as negative 1/3 times positive 2/5, I know right off the bat a negative times a positive is a negative. So whatever my answer is going to be, it's going to be negative in the discussion. Next. So here we go. The first method I'm going to talk about is boxes. Everyone knows how to multiply straight across, and that's the classic method. Boxes for me is more like this. If I have negative 1/3, I'm going to look at that 3, and I'm going to make 3 columns. So I've got my 3 columns. 1/3, and I'm not worried about the negative. I know the answer is negative. I know it's negative. Negative times positive is negative in the discussion. 1/3, well, I'm going to shade this in for my 1/3, and that's my 1/3. Next, I'm going to look at the 2/5. And looking at the 2/5, now this is with rows, the columns is up and down for rows. I'm going to break it into 5 because that is the denominator I have right here. 1, 2, oh, I'm making it kind of narrow, 3, 4, and 5. And I know I have 2/5, so I'm going to shade 2 of the columns. Let's say these 2. So what I'm doing is I am counting how many boxes I shaded with both ways, that are shaded with the columns up and down, and also the left and right. Well, I have 1, 2. These are both shaded that way. If you really want to be fancy about it, you could also do it with color pencils. I would use 2 colors that are very, very different. So like green and blue, maybe would be, or green, let's go with green and purple. Green and blue would be great options. So I colored this one like that. And the blue one I'm going to do like this. Okay. And now I'm going to go through and I'm going to count how many boxes do I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total boxes. And I have 1, 2 boxes that are green and blue, that are both colors. And because I know it is a negative times a positive, and negative times a positive is definitely negative. There we go. So the answer is negative 2/5. Classic. And this is the way that you know how to do. I have negative 1/3 is equal to times 2/5. Negative times a positive, and negative times a positive, period, is negative. 1 times 2 is 2. So I'm multiplying these. 3 times 5 is 15. And if you look, there's my answer again, negative 2/15. Okay, moving on, next problem. Another problem doing with the classic. Well, we have negative 4 and 15ths times negative 3/4. I'm just going to write it down here. First thing I'm going to look at, a negative times a negative times a negative is a positive. So I know my answer is positive. Now I'm just going to do the rest of it. 4 times 3. So again, I'm showing 4 times 3 divided by 15 and 4 is equal to, well, 4 times 3 is 12, and 15 times 4, 5 times, it's my own sharp, my scratch work over here. 4 times 5 is, let's see, 4 times 5 is 20, carried 2. 4 times 1 is 4, plus 2 is 60. So, that's 60 right there. So this is positive 12 over 60. Now the question becomes, can you simplify it? Absolutely. I'm just going to go for the big guns because I'm looking at it and I'm thinking both the top and the bottom can be divided by 12. If you use a smaller number, you have to keep simplifying until you cannot simplify anymore. Do not just simplify one time if you use like 2. You have to continue simplifying until you can't simplify anymore. So I'm going to simplify by 12. 12 divided by 12 is 1. 60 divided by 12 is 5. So there's my answer, 1/5. Well, that's great and everything, but I had to simplify at the very end. And with really big denominators, that can become kind of tricky. Here's another method, and this is breakdown factors. I can take negative 4 over 15 times negative 3 over 4. And I'm actually going to do exactly what I did earlier, except this time I'm going to, well, let's just do it. 4 times 3, 15 times 4. Let's get a little fancy with my balance line. Oh yeah, line up them equal signs. Well, what times what equals 4? I know 4 is equal to 2 times 2, and then that 3 is prime, so I'm going to leave that alone. Divided by 15 is 5 times 3, and 4 is 2 times 2 again. Now that's kind of chaotic. I've got like the big numbers in the front, on the bottom, and the small numbers in the front and the bottom. Here's what I say. I say reorganize to make all the smallest numbers in the front, all the biggest numbers in the back. Because what we're going to do in a minute is that's going to make life so much easier if we do it that way. 2 times 2 times 3, because 2 and 2 and 3. I'm going to put 2 times 2 first, so these are up here. 3 times 5. All first. Now comes the fun part. You just divide. 2 divided by 2 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. And see how they're massive ones? Because this is what I'm going to do. 1 times 1 times 1 is just 1. 1 times 1 times 1, well that's 1 times 5 is just 5. So the answer is 1/5 over here also. Okay, so there's two really simple examples of multiplying fractions. So the next part we're going to jump into is dividing. So with division of fractions, basically here it is. What is being said by dividing is how many of the denominator can be found in the numerator. So how many of the divisor, 3/5, can we find if we break the whole number 3 apart? So here's what I'm going to do. I'm going to split through all these holes, and I've drawn a circle. I'm going to show us the circles first. I'm going to split all these circles into fifths. I'm going to see how many 3/5 can I find within all of those things. My pencil over here. Okay, so first off, I'm just going to break them into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I got my circles broken into fifths, and I'm just going to take a color pencil. I'm going to take a few different color pencils out, and I'm going to see how many different colors can I use. Well, I want to see how many groups of 3/5 can I create. So I've got one set right here. So that's one. Let's use this one. Got one set right here. So that's two. Taking some brown, gonna set right here. And that's three. Okay. And now I've got a bunch of different pieces. So how about this? Why don't we take, let's see what's another color I could use. I got a yellow right here. So I've got two. Plus one more makes three. So that's three. That's four so far. And then let's take this greenish color. I've got one right here. Right? And these two, and that makes five total. So I've got 5 groups of 3/5. 5 groups of 3/5. So my answer for this in this first way is 5. So that's what it means by taking 3, and how many groups of 3/5 do you get? 1, 2, 3, 4, 5. The answer is 5. Okay, now let's go with the classic. We've got 3 divided by 3/5. First thing I'm going to do is I'm going to rewrite, because if you have a whole number, anytime you divide by a whole number or multiply by a whole number with fractions, you got to add a 1 underneath it to make it a fraction also. Next, you can do this a few different ways, but basically here's the main way. I would keep the front the same. This is skip. I'm going to times by the reciprocal. You don't divide by 3/5, you multiply by the reciprocal, which is 5/3. Okay? Because think about it. Here's the main thing I think about. I broke 3 circles, that's this 3. I had 3 circles and I broke them each into 5 pieces. Count how many slices I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different pieces. And I took 15 and divided it by 3. Watch. 3 times 5 is 15. 1 times 3 is 3. And we all know 15 divided by 3 is 5. So 3 divided by 3/5 is equal to 5. But that's a brilliant way of looking at it. I multiplied the numerator and I got my 15 pizza slices. You get 3 pieces of pizza, you get 3 pieces of pizza, you get 3 pieces of pizza. Until, well, how many people is that going to feed? 5 people if everyone gets 3 pieces. So, great way of thinking about it. Let's take it a step further. I've got 4 7s. So first off, I'm going to do this with the circles. I'm going to break it into 7. It's 1, 2, 3, 4, 5, 6, 7. Okay? And, well, I'm going to take my light green, and I have 4 7s right now. 1, 2, 3, 4. So I'm looking at this, and I'm going to take my light blue, and I want to know how many groups of 3. Notice I'm not worried about the negative. A positive divided by a negative, that goes right back to the triangle. Remember, wherever I put it, don't know where I placed it. A positive divided by a negative is a negative. Not worried about that. I know the answer is negative. Not worried about that. That's something that you should be automatic. So I'm thinking, how many 3 7s how many groups of 3 over 7 can I make? Well, here's one group. Oh, this one's, I'm going to go with the darker blue. So there's one group right there. Because I need 3. I need 3 to make one group. So there's one. But if you notice, I've only got one extra piece left over. You need 3 of those you need 3 of those numbers to make a whole. So if I need 3, it's kind of like it actually is a fraction. I need 3. How many do I actually have? I've only got one left. Because I'm missing those other 2. Because I need these 2 right here. So from here to here, I've only got one of the 3 I need. The 7's gone. Yep. I need one. I only have one of the 3. And again, a negative times a positive, or a positive divided by negative is a negative. So my answer should be -1 1/3. Let's go with the classic. Because if we get the same answer with the classic method, then we should be all set. So here we go. For my pencil, sorry. We have 4 over 7 divided by -3 over 7 is equal to, okay. We don't have a whole number, so we're not going to have to worry about rewriting. So we can just automatically go to skip, change, flip, skip this, times this by -7 over 3. What do we get? Now, you're probably looking and you're thinking, can't we just cancel out the 7s? Absolutely you can. If you decide to do that, because I don't want you just crossing stuff out. Remember I talked about this in class. I want to see divide by 7, divide by 7. Because if you're canceling stuff out, that's what you're doing. You're dividing both of those by 7. Because now I've got 4 over 7 divided by 7 is 1 times, well, negative's still there. 7 divided by 7 is 1 divided by 3. Positive times a negative is negative. 4 times 1 is 4. 1 times 3 is 3. And before you say, oh, that's not the same answer, hold on. This is an improper fraction. 3 goes into 4 one time. I have 1 left over for 3. 1 piece left over after broken into 3, and look, there it is. -1 and 1/3. Man, I love these circles, because for me, this really gives me a visual idea of why this works. And it's awesome for really small groups and small numbers. When we get the bigger fractions, not so good to use. But for now, the easy problems, really amazing. Okay, so those are our 4 examples. 2 multiplying, 2 dividing. Hope you got something out of it, and I'll see you next time.